Yes. All right. So I've got you tuned in again, and while that's loading, I've never tried this before. It's saving. I've using this thing at the same time that I'm saving it, so that you're watching this. Um, all right. So here's what we're talking about when we talk about density, and density means it can, density of water. Let's just look at something nice and easy. Density of water. Density of water is 1,000 kilograms per meters cubed. Okay. Well, what's a cubic meter? I mean, really, what is a cubic meter? There I am saving the old one, so there's no way this is going to work. All right, so what's a cubic meter? Well, right here, people, this is a meter stick, okay? This is a meter stick. So if I take this meter stick, there, we can get it into the screen. And if I took something that was this tall, this wide, and this deep, something like this, 1,000 kilograms, that's a lot. That's a ton of water. Okay. So basically your desk or something like that is a cubic meter. All right. So that's that. So anyway, so this is the density of water. That's the density of water. That's rho of water. Okay. The human body. The density of a human body, of the average a human body, is about 950 kilograms per meters cubed. Okay, it's about 950. That's of a human. 950 is less than 1,000. Guess what? We float barely. One of the problems is our head is more dense than water, so our head gets in the water. And then secondly, people panic sometimes when they get in the water if they're not used to it, and it is kind of scary. And I'm not making fun. I'm definitely not making light of people that are afraid of water or that don't know how to swim. But that's the problem: is that the head is more dense than water, so it goes under unless you know how to keep it up. All right. So things float if they're less dense than water. Things float in the air if they're less dense than air, and so the density of air. Density of air. I think we're going with 1.2 kilograms here per meters cubed. So notice that's like a half a pound. In a big aquarium, you've got a half a pound of air in there, ballpark, here on Earth. Okay, and helium has a density of, let's say, 0.95. I don't know for sure, kilograms per meters cubed. So therefore, just like water, so that's why helium floats, right? And when you watch the sulfur hexafluoride little vignettes where that's really heavy, that's a balloon that will not float. That's a balloon, you blow that up and boom, it goes right to the ground. It bounces like a basketball. Okay, a balloon filled with sulfur hexafluoride because it is so dense. It's much, much more dense than 6 times denser than air.